Well, it's officially 2:30, so we can go ahead and get started. I do want to note that the session is being recorded. Unfortunately, we did have a few people who are unable to attend, so we're making sure that they will be able to watch this video in the future. So I get to do the honors of introducing Miss Delaney Demro, who is a master's student with us at ESF. And she came to us about getting close to like 2+ years ago to start her master's degree. She had done her undergrad at the University of Illinois at Urbana-Champaign with a bachelor's degree in natural resources and environmental science, with concentrations in resource conservation and restoration ecology, and a minor in environmental economics and law. Before she ended up joining us, she also did some research work for our Argonne National Laboratory, which really did a solid job of prepping her. She learned how to do water quality sampling, get some really solid skills in GIS, which she definitely was able to bring into the current research project that she's going to be presenting on today. Delaney has been an absolute pleasure to advise and a real rock star, and has brought on some great undergraduates. Jillian, who has since graduated, was one of the team working on this project. But I did want to mention Delaney has also won some awards during her time here. She received the Outstanding Master's Student Scholar from the grad program in environmental science here at ESF. And she's also won a couple of conference paper awards, one at the Northeastern Aquatic Biologist Conference, and the second one at the Natural Areas Conference. And she's also presented in a few other venues. So this work has gotten some attention, including it was part of a local NPR piece when we were in the midst of the research project itself. So without any further ado, Delaney, I'm going to turn over the mic to you and let you explain this wonderful research that you've done with us.
Thank you for that awesome introduction, Angia. I really appreciate it. And I'm glad to see everybody here. I'm so excited to be giving this presentation. And I want to give a shout out to my other project advisors from ESF, but also from the New York State Department of Environmental Conservation. So here at ESF, I've also been working with Valerie Luzatis and Dr. Steve Stamen. And then at the DEC, I've been working with Brian Duffy, Meredith Streeter, Charles Stoll, and AJ Smith. And then also special shout out to my undergraduate aides who helped me do the field research part of this project, Jillian Hall and Colin Gerlach. So let's get started talking about the citizen recreational evaluation of environmental quality and how we are linking public perceptions to the biochemical measures of stream water quality. So an overview of this presentation, I'm going to first go through some background information for the CREEQ project, and then I'll describe our methods, go through our results with a little bit of discussion about what they mean, their potential causes, and how these relate to previous findings in the literature. And then I'll walk through our conclusions and we'll wrap it up with some Q&A. So I'm going to have these introductory slides for each section. And I just want to note that all the pictures on these slides were photos that we took while out in the field sampling. So as someone who grew up in Illinois, it was really awesome to be able to travel to all these locations as part of my research. So I just want to showcase these a little bit. So the motivation for our project really came down to monitoring water quality. And the importance, I first wanted to emphasize this, the importance of monitoring water quality is that surface waters are used for a variety of reasons, which include drinking water, recreation, and habitat for aquatic life. So without protections of these waters, they could pose risks to the health and safety of not only human life, but also the natural world. So when the Clean Water Act was enacted in 1972, it required states to establish narrative water quality standards to protect these common uses as I described. However, more recently in the early 2000s, the EPA has since required states to develop numeric criteria to identify specific threshold in nutrients and other pollutants in like the water's chemistry to improve the accuracy of monitoring water quality to protect these uses. So to understand how water chemistry interacts with these uses, I'm going to focus specifically on recreation and aquatic life. Many state agencies have performed assessments to establish these criteria. However, most commonly, stream assessments have been focused on aquatic life, where for lakes, there's been a larger focus on recreational uses. And while this prioritization has really optimized the benefits that the environment and people have received from these protections, it's created a gap in knowledge for understanding how stream water quality affects our ability to recreate in these systems. And I just want to note that there are two main types of recreation. So first, primary contact recreation, which is where people come in direct contact with the water. So this includes swimming and wading. And then secondary contact recreation is where people come in indirect contact with the water. So for example, boating or fishing and that kind of stuff. So now that I've established the motivation, I want to further explain some background about how people's perceptions of water quality and their recreational usability are affected by both social and physical factors. So initially, people's perceptions are influenced by what they can see, feel, and smell while they're at the stream. And many studies have found this, that there has been a strong influence for the observable cues like water clarity, algae, and odor strength, and others like that. And so then after people notice these features, they are able to form opinions about the water body and their ability to recreate in it. And these are influenced by their knowledge and attitudes about the environment, but also their experience with different types of water quality conditions, and also their intended use for the water body, or what I like to call the interaction effect, since previous studies have shown that how someone plans to interact with a body of water will change how they perceive it and what factors they really focus on and consider. So for example, if you're at a river that has dense algae all over the top, you probably wouldn't mind putting a boat in the water. I mean, it's not ideal, but you would probably rather put a boat in the water than go for a swim there. And I also really liked this graphic from West et al. That was published in 2015, because it shows the relationships between the water chemistry, the visible factors of the stream, but then also people's perceptions and the social drivers that influence those perceptions. So this was a perfect diagram to show the thought process that we also used in this study. So next, I wanted to explain the relationships between the observable conditions that influence people's perceptions and the water chemistry vectors and consequences of these conditions. So vectors are the water chemistry parameters that cause the changes in the stream's appearance, and the consequences are those that result from those changes in the stream's appearance. So, for example, primary nutrients like nitrogen and phosphorus, these drive the growth of algae, aquatic plants, and biofilm, which can also result in odors and changes in the water color. And then another factor is water clarity can be a result, or decreased water clarity can be a result of elevated concentrations of turbidity, but also chlorophyll A, which is a measure of algal growth in streams. So turbidity is a measure of water clarity and like water visibility. And that can be made up of suspended sediment or algae and other dissolved matter. And suspended sediment can be often bound with nutrients and other pollutants that can further drive the degradation of the stream and its appearances, having a cascading effect with other observable features. So the CREEQ project was built from previous work performed in 2015 by A.J. Smith, Brian Duffy, and Margaret Novak of the New York State Department of Environmental Conservation, or DEC, as I'll mention throughout later on. So this DEC project had members of their stream assessment crews perform the user assessment of recreational usability survey during their routine monitoring efforts. And the results of this study showed that there were direct relationships between perceived recreational use and water chemistry parameters like nutrients, nitrogen and phosphorus, chlorophyll, a measure of algae, and turbidity, a measure of clarity. So given the success of that project, the DEC had connected with ESF faculty to adapt the project for public use through the application of social science methods. And so that's how we created this study. So we wanted to do that to test if similar results could be found through a citizen science effort. And if you're unfamiliar with what citizen science is, it's described as the involvement of public or non-professionals in research, and it's most commonly done through data collection. And I just want to note that the term citizen used here and throughout our study refers to any member of the community, regardless of citizenship status. But we chose to use the phrase citizen science because the methods of our research don't meet the definition for community science as defined by the Community Science Institute. Overall, there are a lot of benefits to citizen science efforts, like the ability to collect larger volumes of data at higher spatial and temporal resolutions compared to those with traditional methods at extremely lower costs. And so for a state agency who is trying to monitor streams that are spread out, all the way across the state and can change very rapidly, a tool like this could really help them identify problems that they wouldn't be able to beforehand. And so that kind of leads into the hope for the CREEQ project was if everything went well, that the DEC hoped to potentially use a citizen science tool such as CREEQ to help inform their monitoring efforts to identify impacted streams throughout the state that they otherwise wouldn't have known about. So I already kind of said this, but the purpose of the CREEQ project is to determine the validity and efficacy of using citizen science data to identify water quality issues in streams across New York. And our research questions include: 1, do relationships exist between public perceptions, stream chemistry, and public reported stream conditions? 2, do public reported stream conditions compare to those by a trained field crew? And 3, do the public's recreational and aesthetics perceptions compare to those of a field crew? And 4, considering the responses that we get from 1, 2, and 3, can citizen science data, specifically from the CREEQ project, be used to help inform stream monitoring efforts across the state? So now moving on to our methods. So our study components comprised of three main parts: the public survey, which they reported their observational report of the stream conditions and their perceptions of recreational usability and aesthetics. And then the field crew follow-up sampling activities. And then the last phase was our data analysis. So the study took place between late May through mid-September during the summer of 2020. And it was within the greater central New York region, which consisted of all counties within a 50-mile radius from Syracuse, New York. And the survey that we designed was intended to be performed at any public access stream or river within this area. So first, to ensure that the study area encompassed the full range of water quality conditions found throughout the state, we compared the biological assessment profile, or BAP scores, from within the study area compared to the entire state of New York. And a BAP score is based on multiple metrics of aquatic macroinvertebrate biodiversity, or the biodiversity of water bugs within the system, since changes in the biodiversity of these communities has long been used to identify impacted waterways. Since any changes in the water chemistry, you might see a change in that diversity of insects. So since our study occurred during the first summer of the COVID-19 pandemic, we had to get a little creative with how we recruited participants. And as Andrea mentioned, we did have to do a local NPR announcement to kind of help get the word out there. But we also had announcements in the DEC's Making Waves newsletters, on-site posters, which you can see here. And we hosted a couple webinars as well. And in addition to recruiting participants, we developed resources to encourage and support their participation. So I created an interactive map that had all public access stream locations within our study area to kind of help guide people, give them options for where they could go to perform the survey. And then I also created a data portal, which was updated in real time with the public survey responses and the field crews survey responses. And also, once we received the results, the water chemistry data was also added for each location. So for the CREEQ survey instrument, we adapted the DEC's user assessment of recreational usability survey that was used by their field crews in that 2015 study I mentioned before. And we adapted this for public use. So, but before developing the CREEQ survey instrument, we actually went out into the field with one of the DEC field crews and were trained on their survey instrument to learn how to assess and report stream conditions. And the CREEQ survey measured the same parameters as the DEC survey, but in a more standardized way that was made accessible for non-professionals. And the design of the survey was made so that anyone could perform it without prior training, since we added additional directions, descriptions, and definitions throughout the survey where we felt were necessary. And to give you a quick look at what the survey looked like, I want to do a brief example at a location that a lot of ESF students and faculty are probably very familiar with, the Erie Canal. So I'll give you guys about 10 seconds to look over this photo, and then I will walk you through some of our questions included in the survey. So first we'll go through some of the stream conditions. Overall, there were 9 questions or 9 features that were assessed, but we're just going to go through 3 of them real quick. So one of the questions was reporting the amount of algae that was present. And so looking at this photo and just also knowing the Erie Canal in general, I'd say that the algae here was pretty dense, as you can probably see from this photo, a little bit of a close-up there. And then similarly with aquatic plants, it's a little difficult to see in this photo, but that little squiggly stuff there in the bottom photo, those are actually aquatic plants that are just covered in algae. So we'd also say that that was pretty dense. And another question, and I really wanted to include this one because we had the most descriptions and directions associated with this question for water clarity, which ranged from very clear to not clear. So we added the description that very clear, select this one if you can perfectly see the stream bed, and then not clear if you can see less than 6 inches into the water. And so for this example, I'd say it was slightly clear because you can probably see about a foot down. So now on to the perception section of the survey. We asked the same set of questions for all of our recreation activities. And this was one point that was a little bit different from the DEC survey, is that we broke each activity down separately rather than grouping them together by contact, but we still use that contact grouping later on, and as I'll show you. So our activities included hiking, paddling, motorboating, fishing, wading, and swimming. But I wanted to go through an example of swimming because I thought that the Erie Canal was a very good example for this, for how to answer these questions. So our first question, or the applicability question, is whether or not it's possible to do that activity there. And here you focus just on the depth, width, and the flow of the stream. And so the Erie Canal, I mean, it's technically deep enough and wide enough and, slow moving enough for you to go for a swim there. However, given the dense algae, dense aquatic plants, and low water clarity, at least personally, I'd say it's not suitable for going for a swim. But if participants did say anything other than not suitable, they'd be asked this last question, their willingness. So if you said it was slightly suitable, would you be willing to actually go for a swim here? And then the last question for perceptions was aesthetics. So overall, considering the stream conditions that you evaluated earlier in the survey, what would you describe that there were no aesthetic problems, some, or a severe amount of aesthetic problems? So on to what we did as the field crew. Once we received a survey, we would travel to that location within 3 days or prior to a rain event. And we would only respond to surveys that were performed at streams and rivers within the study area, because we did get a few that were done at ponds, lakes, and some that were just way too far away for us to get to. But once we did get to the location, we performed the CREEQ survey, the same survey as the public, but we also documented some site characteristics and performed water sampling activities. So for the water sampling, we were trained by the DEC. We did spend a little bit of a field day with them to make sure that we were using the proper techniques and everything like that. So before doing our data analysis, we did process the data a little bit. So this is what I was alluding to beforehand. We grouped the responses for each activity, the applicability, suitability, and willingness questions into one recreational perception metric to determine a recreational perception impact score. And then using that metric, we further grouped them into primary contact. So we grouped responses from wading and swimming, and then we grouped paddling, boating, and fishing for the secondary contact recreation. And all of our analyses were performed using SPSS statistics. So our analyses, at least our primary analyses, included the Wilcoxon matched pairs test, We use this to answer our first two research questions to identify differences between the participant and field crew reported stream conditions and also their perceptions of recreational and aesthetics. And then the next metric or analysis was the Kruskal-Wallis independent samples test. And we did 3 of these to identify the third research question, to identify relationships between the stream conditions and the recreational use perceptions, and then to find relationships between stream conditions and water chemistry, and then perceptions and water chemistry. So these 3 pieces together tell us which stream conditions negatively impacted the participants and the field crews' perceptions, but also how the stream's chemistry related to these conditions and their impacts. So once we consider the results from all of these analyses together, we're able to answer our 4th research question to determine the validity of using citizen science responses to identify recreational use and water quality impacts in streams. Moving on to our results and discussion. So quick overview of the results I'm going to be describing. First, I'll go through some of our descriptive stats and then the comparative analyses that I just described a second ago. So overall for our participants and our samples, after applying the inclusion criteria for the 3-day or before rain and within the study area at streams, we had a total of 48 participants, 79 survey responses, and at 60 locations, which you can see mapped out here. And I included a couple demographics because I thought that these are pretty interesting about who our participants were. About half of them were between 18 and 35 years of age. About a third of them were female. And this was the most surprising bit, that 73% of them, this was their first time participating in a citizen science project. Also, just over half of them self-reported to have moderate to excellent water quality knowledge. And this is an important note that'll come up later on as well, that 82% of them plan to recreate at the stream where they were performing the survey. So a description of the stream conditions. All of the stream conditions were not normally distributed as reported by the field crew and participants. They were heavily skewed to the left, meaning that there was a higher frequency of streams with less severe conditions, meaning there were more streams that had no trash, no algae, and very clear water. And so this resulted in us needing to perform the non-parametric analyses that I described before. And another interesting note is that about 1/3 of the time, the participants reported conditions as less severe than the field crew. And so this is really apparent with algae. As you can see on the chart here, the blue bars are participants and the green is the field crew. That participants said that there was no algae at about 50% of locations, where for the field crew, they reported this at only 20. And so you see that shift. And then we had a similar thing happen with recreational and aesthetics perceptions. Again, all of them were not normally distributed, meaning that there was a higher frequency of less impacted perceptions and fewer aesthetic problems reported. And also actually over 1/3 of the time, participants' perceptions were less severely impacted than the field crews, which again, you can see here that for weighting perceptions, the participants' perceptions weren't impacted at 70% of the locations they went to, whereas for the field crew, this was only about 40% of the time. And similar thing with water chemistry. Again, they were not normally distributed and they were heavily skewed towards lower concentrations. And so a potential cause for all of these is that 96% of the surveys were performed at public recreational areas, meaning that like these areas are typically better managed to protect these uses, and also people's perceptions of recreational usability at somewhere that's designated for recreation. It's probably less, it's probably more likely that they will perceive it as usable if that's what it's meant for. So now for our first comparative analysis, comparing the participants versus the field crew responses. Overall, the participants were not as effective as the field crew in reporting stream conditions, since their reports significantly differed for all conditions except for total pipes, water clarity, and aquatic plant density. We're not going to focus on total pipes because there were actually only 8 locations that had pipes present. So the reason for that relationship we're thinking is because the majority of places didn't have pipes. These differences were not really expected. I guess it was kind of an assumption that people would be able to report stream conditions consistently with the definitions and directions provided within the survey, but that is not what we saw here. So another comparison between the participants and the field crew's perceptions, they all significantly differed again, except for paddling, boating, and swimming, and primary contact recreation. But again, we're going to skip over the first 3 because the sample sizes were too small for those activities, because there weren't enough streams that the surveys were performed at that you could go like kayaking or paddling, motorboating or swimming there. And these differences were expected because everyone's perceptions of recreational usability and aesthetics are going to be very personal and subjective. So we weren't too surprised by this. So a little bit of a discussion about why we think the differences in stream conditions why those were so significantly different between the participants and the field crew, really based on their knowledge and experience and training. So the field crew, just as part of working on this project, we visited over 100 different stream locations. And so we were able to see that wide range of what streams could look like and what the conditions could be, where with someone who's just, visiting streams for recreation, casually, they probably don't see that many and don't travel too far outside of their local area too frequently. And something else that could have affected the differences we saw between the recreational and aesthetic perceptions, as I mentioned before, the interaction effect, but also that 73% of our participants were first-time citizen scientists. That relates more towards the differences we saw for the stream conditions, but it could have had an effect here as well. And then also 82% of participants plan to recreate while visiting the stream. So since they were already planning on interacting with the water, their perceptions of its usability might have been skewed towards less impacted, since that's what they were planning on doing while they were there. And then, as I mentioned beforehand, the surveys were performed at a majority of public recreational areas. So knowing that that's what it's used for, people are probably thinking it's not so bad. So now we're looking at the relationships between the participant reported stream conditions and their perceptions of recreational usability and aesthetics. I really just wanted to show this table that shows the p-values or significance levels for all of these potential relationships. to compare it to what we saw from the field crews. So just looking from what we saw with the participants and the field crews, you can see that there were many, many more significant and much stronger relationships with what the field crews reported stream conditions with their recreational and aesthetic perceptions. However, there was one condition that their perceptions did not completely differ from, and this is also the one stream condition that the participants were as effective at identifying as the field crew. And so you can see here on these charts that both the participants and the field crews' primary contact recreational use and aesthetics perceptions were significantly more impacted with decreasing water clarity. And so you can really see that trend here on the bottom left chart with the decrease there, and then on the top left chart with that decrease there. So an explanation for why this could have happened, especially in the literature, there's been well documentation of people's perceptions of clear waters versus murky waters, because clear water indicates good water quality. It's typically more aesthetically pleasing, and it's especially more preferable for primary contact recreation. We are actually going to be submerged in the water. And it appears from the relationships we saw that there's likely a threshold between people's recreational perceptions between mostly clear and slightly clear waters, that we saw this for both the field crew and participants. So in addition to the relationships that we saw for both participants and the field crew, these were some additional ones that the field crew's perceptions and reported stream conditions were. So an explanation for those, trash both impacts aesthetic value and can cause a site to be perceived as poorly managed. And some studies have also found that if there's trash at a location, people are more likely to continue littering there. And so it's just less appreciated. And algae can physically impede recreation. So, if you want to go for a swim or if you want to put a boat in the water, it can really make it difficult to do so. Not only that, it can impact aesthetic values and indicate pollution. So this explains why we saw those decreasing recreational values with increasing levels of algae and trash. And also for odors, this one was kind of unique because especially in the literature, they found that regardless of the stream's appearance, if there's a strong odor presence, people's recreational perceptions seriously decrease because it indicates that there's something weird going on there. And then other important relationships to note from the field crew's perceptions and reported stream conditions were those between aquatic plants and biofilm, because both of these can impact aesthetic value, but also be a nuisance for recreation. So aquatic plants, similar to algae, it'll prevent you from being able to do this, easily. But biofilm, it can also be an indicator for pollution and nutrient enrichment. So our next comparison is going to be between water chemistry and stream conditions for the participants. And you can see here that they had a good amount of relationships between water clarity and these chemistry parameters. And again, with the field crew, we saw many, many more significant relationships with the stream conditions that they reported and the water chemistry. And as I did with the last one, I'm going to show you an example of where the field crew and participants were similar. So there were, increasing concentrations of total phosphorus, chlorophyll, and salinity as water clarity decreased, and concentrations of dissolved oxygen also significantly decreased with decreasing water clarity. And this was found for both the field crew and participants. And so, as I mentioned a little bit in the introduction, the importance of this relationship with water clarity and these water chemistry parameters is that it shows potential causes and effects of this appearance in the stream. Skip that one. And then our last relationship, our comparative analysis results, is comparing water chemistry by perceptions. Again, with the participants, we saw very few significant relationships, but again, there were some that both the participants and the field crew were able to obtain. So for both the participants and the field crew, concentration of dissolved oxygen significantly decreased with their secondary contact recreational use perceptions, and concentrations of chlorophyll significantly increased with increasing aesthetic problems as perceived by the field crew and participants. So now moving on to our conclusions. So to answer our first two research questions, how the public reported stream conditions and their aesthetic perceptions, or aesthetic and recreational use perceptions, compare to the field crews. So the participant reported observations were overall inconsistent with the field crews, except for water clarity and aquatic plants. And then the participants' perceptions were inconsistent with the field crews as expected, except for primary contact recreational use. So for research question number 3, do relationships exist between public perceptions, stream chemistry, and public reported stream conditions? Yes, kind of. So participants were able to identify stream water clarity as effective as the field crew, while showing similar relationships with phosphorus, chlorophyll, turbidity, percent saturation, dissolved oxygen, and salinity. However, the participants' perceptions did not have significant relationships with these water chemistry parameters, so it just stopped with the perceptions with water clarity and then clarity with the chemistry. And then for their aquatic plant relationships, they had a significant relationship with chlorophyll A, but this could have been caused from a difficulty distinguishing between algae and aquatic plants, since there were no recreational or aesthetics perceptions related to aquatic plant density, and only their aesthetic perceptions related to chlorophyll. So further meaning that could have been just from algae. And our final research question, can citizen science data be used to help inform stream monitoring efforts? We want to say yes, but with some training, mostly because of the training that the field crew received. It was very minimal. We spent maybe 4 hours in the field learning how to use the survey instrument, and then 4 hours in the field learning how to collect water samples. And since the participants were already able to accurately identify water clarity, they do show some promise that they already know how to at least somewhat assess stream conditions. So our recommendations for future studies is to perform this study again, but to see if there is a difference with that minimal training to improve their accuracy of stream condition reporting. And so our hope for that is that it would control confounding variables like people's experience and knowledge. And we would suggest some training options I would say virtual is probably the best way to go, since we've already seen other citizen science efforts like eBird from the Cornell Lab of Ornithology use these like online videos with quizzes to help people more accurately identify birds. We can use a similar way for people to accurately report stream conditions. And an additional recommendation is to perform the study at specific locations that we know cover the range of the stream conditions without the state, rather than having the streams people evaluate, at least for the study, on a voluntarily chosen basis at recreational areas, because this removes the bias of their intended use, but also increases the distribution of the stream conditions we would get, kind of hopefully evening out that skew that we saw earlier on. So how this information can be used: after establishing a baseline, we suggest that recreational use perceptions no longer need to be collected from the public, only up to the point where we have enough information to identify those pollutant thresholds and like criteria to protect stream recreation. But as a screening tool by the DEC, we suggest that only stream conditions need to be collected and reported to help them identify impacted streams in the future. And that wraps up my presentation. I want to say thank you guys all for listening, and I'm ready to answer some questions.
Thank you so much, Delaney. Good job. Okay. I would now like to open the floor for any questions. Feel free to either place them in the chat or unmute yourself long enough to ask a question. Would anybody like to start? Brian, did you have one?
I had a handful here. I was just waiting to see if anyone else wanted to ask them. Some that I might know the answers to, but others that, you know, I was hoping to get your thoughts on, Delaney. And I guess I'll start with the one I just wrote down because you just mentioned it. Can if you would you go back to that last slide and your very last point? I just wanted to get some clarification on that last point about, as a screening tool, this only stream conditions need to be collected to identify impacted streams. Can you just describe what you mean by only stream conditions need to be collected?
Right. So as a citizen scientist, at least I'm suggesting that just that portion of the survey would be enough information to indicate what streams are impacted, at least after we do a additional study with the training to see how those stream conditions relate with the water chemistry.
Okay, so you mean we don't have to collect the chemistry as well because you have a pretty good idea based on the analysis that water chemistry is going to be one thing or the other based on the responses?
Right.
Is that okay? As a screening tool, right? Exactly. Okay, I got you. Thank you. All right. So I guess I'm kind of working backwards here in my questions that I wrote down here. But you know, you touched on the ability of the ESF crew and the sort of perspective gained through training and their ability to maybe more accurately use you know, their perception to identify the water quality issues. Do you think it was the training, or is it, you know, did you guys get better at it because you were able to see so many streams? You know what I mean? Like part of one of the things, and this is related to one of my other questions, one of the shortcomings of the initial Smith 2015 paper was that we have this statewide perspective, and you know, how well do we represent public perception when we go all over the place and see this broad range of conditions and have this perspective? Do you think it was the training, or was it because you got to see so many streams within your 50-mile radius?
I want to say both. And so I guess when I said training on the survey instrument, that also played into our ability to see all these different locations. And so that ties into my suggestion for training participants is, giving them pictures or like video examples of what, a healthy stream versus an impaired stream looks like, to give them that experience that we were able to gain in the field.
So providing that perspective more directly in training materials, whether
Right.
they're virtual, YouTube videos, various ways of just kind of describing and displaying the actual variability in the range we see out there compared to what they maybe are used to seeing.
Right, exactly.
Okay. All right. Anybody else? I can keep going.
I think I see a couple in the chat. Oh no, there's just say they have to go. That's all right. Thank you, Teresa. Brian, you want to keep going, or does anybody else
Sure,
got something
yeah.
for me?
Well, if anyone else has one, I can hold off for a minute.
I do want to ask, and Jillian, I don't mean to call you out, but as someone who helped in the field, do these findings fit with what you were thinking?
I don't know. It's been so long, but I kind of was a little surprised seeing the analysis and seeing what did line up. I was a little surprised, yeah. But it was so cool to see everything come together. Congratulations.
Thank you.
So I guess my question, about the perspective gained, Jillian, you maybe started off pretty fresh. Did you, can you speak to that point at all? And like as a sort of trained volunteer, how you gained that perspective?
Oh, yeah. So at the very beginning, we did an intercoder reliability test. And during that, we talked a lot about how to answer those questions most accurately. And I think because of that, I was able to answer a lot of the survey questions with a little bit more insight and knowledge on water quality. And obviously, citizen participants didn't have to do that. So we talked about like, what is an accurate answer for water quality? And it was like, I can see 1 to 2 feet or 2 to, I can't remember what the exact numbers were. But that definitely, having that kind of training helped a lot. Yeah. Did I answer your question?
Yeah. Yeah, because I think as we're talking about it here, one of the things that would be useful is sort of recommendations on how to put together a training if we were to do that. And if we're going to talk about how to take CREEQ further and incorporate it, what do we need to do to make sure that people are trained, quote unquote, and able getting good responses?
Yeah, I was wondering the same thing. Would it have to be like a designated group of people that sample, like kind of like what the DEC did previously, but with citizens instead?
Yeah, and the training program I think would be really important if that is the key to getting good citizen science data. I think we'd need to take some, or consider how to develop that effectively. If I could keep going, I just wanted to get Delaney a couple more thoughts on some items. You didn't talk a lot about the actual concentrations for the water chemistry parameters that we measured. Certainly the relationships that we're seeing, but when you categorize the different levels of impact, were you able to discern any sort of thresholds for what we might consider impairment based on, if not the citizen responses, your own? Like where do we see the user perception go from I would do it to I just wouldn't do it anymore, and it's maybe impaired from a recreational perspective?
Yeah, we did see a handful of those where it was very evenly divided, either between very clear waters. This is just an example. I'm not sure if this is the exact relationship, like very clear was significantly different from anything worse than that. And then we also saw splits right down the middle, as I mentioned in the presentation. So I'll definitely dive into that more in my actual thesis.
Okay.
But also with like the water chemistry itself, I did compare it to the findings that you guys had in the 2015 study, then also previous like criteria for what's considered eutrophic or nutrient-rich streams. And our water chemistry only had a few outliers that met those values. So they just weren't as impaired from like a water chemistry standpoint than previous studies. Yeah.
So the range of impact and enrichment from a water chemistry perspective maybe didn't reach the same extent that we captured statewide in that initial one.
Yeah. Yeah.
Okay. I saw Charlie just had a question in the chat.
Oh, yep.
I can read it out loud. You
Okay.
said, based on your experience completing the surveys and through your analysis, would you recommend a survey redesign that focuses on certain aspects of the current survey and or excludes other portions of it?
I would say I could see how that would be useful. I'd definitely have to sit down and look at it more thoroughly to give you a more specific answer. But I guess that does touch on why I was suggesting just focusing on the stream conditions, since it appears that recreation perceptions aren't as well of an indicator for water quality impairment as the physical appearances that they respond to form those perceptions.
And I wanted to jump in on that, Delaney. So a lot of the people were recreating. And so that did send us into a scenario where people weren't going to highly impaired systems. So we weren't getting those really represented too much in our sample, right?
Mm-hmm.
And this was also happening during COVID lockdown, which meant it was a very interesting time to be doing data collection. But do you think that the fact that there was people that were trying to, because what we saw at a national level was a lot more people trying to recreate outdoors as something to get them out of the house. Do you think that's why another potential reason of why you had so many samples at recreation areas?
Yeah, absolutely. And I guess also in addition to that, early in the study season, Jillian and I went out and put up posters at common recreational areas. And so people who maybe haven't heard of citizen science, which explains why we had so many first-time citizen scientists, they saw the poster while they were just so happened to have been there and participated in response to that, as something more for them to do while they're out of the house. So who knows? Yeah.
Yeah, another thing that I wonder is if we had a group of citizen scientists that have participated in another program like the WAVE program and had, that population as a comparison group to see, would they have been better than what is seemingly a bunch of first-time citizen scientists. And I think another thing that we had talked about is we had some people who did more than one sample.
Mm-hmm.
And from that perspective, I was almost wondering if, and we couldn't determine this because the sample size was way too small, but if they improved over time because they had trained themselves on the instrument, did they get better? Because I think through your training of like intercoder reliability and like training yourselves on the instrument, you did well. And so I wonder if that's kind of like another element, if they were just kind of gradually training themselves to view these systems.
Right. Can't really speak it too much
Unfortunately,
more. Yeah.
Okay,
But-
any other questions from the group? Okay, we are at 3:30. So I would like to thank everybody for showing up and supporting Delaney today. And I also wanted to say a special thanks. Dr. Valerie Luzatis was not able to attend this session, but she is the co-major professor. So we will be, for the committee and our examiner, Delaney, we will be talking more about this project in the near future. But thank you, everybody, for showing up and listening to Delaney's great work.
Thank you, everybody.
Nice work, Delaney.
Thanks.
Good job, Delaney.
Congratulations.